service will be topic 2. Of that, and then you go open up the Word document. It's pain and horror. But version control's goal is to help prevent this nightmare by giving you actual tools to make it possible to see history, to see changes, and so forth. So Git is a version control tool, but it's primarily used for code, and we'll get into the details of that. But before we dive into Git, I thought we'd step back and look at FOSS VCS history. VCS is version control system. FOSS, if you're unfamiliar with that term, is free and open source software. You might either also see it as just OSS for open source software, or there's a FLOSS variant, which stands for free Libre open source software. They all mean the same thing, but I wanted to take a little trip down memory lane. Can anybody take a guess as what I have is, this is chronological. First FOSS VCS tool that would be on that list.
The one before CVS is the one I started with, SCCS or something.
Oh, I forgot about it.
RCS and SCCS.
RCS is the one I put at the vet. Man, missed it. Shoot. But
so you're gonna have to do another commit on this.
It's funny you say that. This is actually version control. This entire presentation is generated with a markdown file that then gets run through JavaScript to produce the presentation. So it is versions as well. So RCS was the first tool. I may be on the younger end of the spectrum for some people in this room. This was actually created a year before I was born. So there's like really no excuse to not be using version control in 2016, 1982. That was a while ago. Next tool on the list, can anybody think of what it is? I've already heard the name, but CVS. Sorry, guys. CVS, 8 years later. What I found interesting, like I didn't actually know any of these days before I put this presentation together, so it's sort of interesting. Like I didn't realize RCS has that much lineage and history to it. And then so CVS came out about 8 years later. The idea behind this progression is like the industry started learning better and better practices. I'm not going to go into all the details of why RCS or why CVS was better than RCS and following tools were better than their predecessor, but we'll see. We'll just want to give you an idea of how long this has taken and how much this has matured. Thoughts on what would be post CVS? Subversion. Subversion came out.
A step backward, by the way.
Do you think? Oh, well, okay.
Yeah.
There's
That's why we don't want to get into
To be honest, that was my first experience with version control.
Subversion?
And it was painful.
Bad start.
Yeah. What I know about Subversion from CVS is, at least at my surface level, is that Subversion did better management of, like, if you move files, it did better tracking of that history.
Kind of,
but
yeah. So they all sucked at like merging. Yeah, they were all bad.
Right. Yeah.
They all sucked at merging. So I think that's what Git tried to solve.
Right.
Yeah.
So yeah, core to these tools that I have listed here is that there was like a central server that backed them, right? So you had to be online, networked, able to reach the server if you wanted to participate in version control. Which gets us to our next set of tools. I'm just going to jump the gun here. Bazaar. This is GNU Bazaar is the official name, and that's Bazaar like as in cathedral versus bazaar if you've read Eric Raymond's post. But I've got distributed there for a reason. There are two other tools that were in this kind of horse race at the same time. Another one is called Mercurial, and then finally, the topic of today is Git. And then there's tons of others. So I'm like you already mentioned one that I've forgotten. There are others that are just around the same but are less popular. But these are kind of like, in terms of open source tools, these are the ones that hit the highlights over the years. Interesting note, like, what the heck happened in 2005? That was a really rocking year for version control. Distributed concept, I guess, took real hold, and we'll talk about what that means in a minute. But I also, before I proceed, there's some dishonorable mentions as well. This is
yeah, I was just going to say, what's DSS?
Yeah, exactly. So
belongs.
if you've been doing software development for long enough, you might have experienced some of this pain. I was actually a rational, well, then became IBM ClearCase administrator for a little while, so I had extra levels of pain in my world. And then Visual Source Safe, I've never heard anyone speak any good of Visual Source Safe
I
ever.
checked files into Visual Source Safe, and it fixed the line terminations for me. It drove me nuts. It changed all my line feeds to carriage return line feeds, and I just wanted to blow the whole thing up.
Awesome.
And my company treated it as a share drive.
Okay.
That's basically what it was.
Wow.
Put it on VSS. Okay.
Yeah. So, so you can see there's some definitely deserved ill will towards those tools. So that's a little bit of the history, but let's talk specifically about distributed. So I listed Bazaar and Mercurial and Git as distributed. What does that mean? In distributed version control systems, you have the entire repository's history wherever you have a checkout or a clone or whatever they want to call it. So when your repository is on your box, you have all the history all the way back to the first commit, which is extremely powerful, because what it means is that all your operations that you do to interact with your version control system are really quick. So if you need to figure out who changed file X a year ago, you can do that operation. It doesn't have to go talk to a server to negotiate, like, what is the history of this thing, and figure all that out. It's all local. So the impact of that in your development speed is just night and day difference, especially if you are on a terrible network. It also has some good side effects of, if you are on a plane, you can write code and have the benefits of version control that you couldn't have if you were doing CBS or Subversion. You have just a checkout there. The second bullet point is a little bit nuanced, but it's the primary point here is that branches are cheap in distributed version control. So you start in these systems. If I don't know how much experience, like you said, you don't have a lot of Linux experience, you maybe not have a lot of version control experience, but you have a main branch of development where all of your work happens on. And when you want to make a change in these tools, what you do is you branch off. You say, I'm going to work over in my little sandbox over here. And you make your set of changes in an atomic way so that they're a consistent set. And then you bring the whole set of changes back to the master branch. If you're working on, let's pick on Subversion. The second bullet point is a little bit nuanced. If you're working on Subversion, and you have a bunch of people working on it, and everybody's working on trunk, is what they call the main branch on there. You can make one commit at a time, and every time you go to the server, it's going to pull down whatever everybody else's work was. So that could really mess with your environment. So Johnny did some change over here that broke your environment, and now you're not sure if your changes are what broke things or if his changes are what broke things, and you have to tease that apart and figure out what just happened. With a distributed system, that's not really a problem. You're in isolation. You know if it broke, well, you broke it. And good luck. And then the final point, resiliency to data loss. It's kind of mostly a nice to have side effect, just because of that aspect of that your entire repository is local. It just comes along for the ride. So if your Subversion server blows up, you might be hosed, or spend a bunch of time doing data recovery, worrying about a host of problems that could happen there. But with a distributed system, that's not really an issue. As long as somebody has a copy of the repository, you have at least some version of the system. that's all I really wanted to do for backstory. I just want to give you guys an idea of what version control systems are about and how they've progressed over time and how the industry is getting better. Thank goodness. So let's talk a little bit about Git itself. We have some boring steps to go along here. These are just installation commands. So you got to start by installing the tool. Git is mostly a command line tool. There are windowed versions if that's your thing, but I'm not going to be talking about them here. I'm not crazy about them. I think they kind of hide a lot of the power. These are instructions for just popular systems that will install Git for you. But the first thing you do, so you've now installed Git on your computer, and you open up a bash terminal. Git requires a little minimal amount of configuration, and that configuration is merely to identify you as you're making changes. So when you make your changes and you do a commit, it slaps some information on that commit so that it says that Matt committed this stuff, and when you need to go check on that version history, you can find out who was the actual culprit or person to praise, depending on your point of view. I think strictly only the email parameter is required by Git, but it's very common to provide both a username and an email. And of course, it hopefully goes without saying, but you don't need to provide real stuff in there if you don't want to. So if you have an alias online and you sensitivity to privacy, you could put in your code name or whatever.
I think it just warns you. It doesn't stop you from committing. It just complains.
Right. Yeah, I don't know. I don't remember if it's required for GitHub or not. But yeah, you're right. That's true. So when you run these commands, though, where do they go? All your stuff gets dumped in a file that's a hidden file in your home directory by default, and know that there are other locations that it can go, but this is where this information is stored. And this information it's not a binary file. It's nothing magical. It's really literally just an INI style file that, wow, it's a little blurry, but has the information that maps here. So it's namespaced, so user is user, name is name, and I just added one for giggles. That is a useful one. The default Git turns on color by default now, so you don't have to worry about it. The older versions, it was all black and white unless you added that option. But it's a very easy file, so you don't have to, if you know the command line or the configuration parameters that you want, you can just edit this directly. You don't have to go through git config. It's just a convenience. And for the gory details of Git and how to configure it, that's blurry, but that's git config --help. It has literally every configuration option that's available in that documentation. It is a manual page that is really, really long and very informative. So at this point, if you were to follow along in this, you would be, in theory, ready to go with your Git client and ready to do some work. So let's talk about GitHub, and Paul might take issue with this slide a little bit, but GitHub is the default. I'll emphasize default. Default place for Git repositories in the software industry, and de facto. That's another. Yeah,
They're all alternatives.
Better term.
Not official.
Commonly used.
Yeah. So the question I thought to myself was why. And these are kind of silly reasons that I was coming up with, and really the more I thought about it, the more I realized, hey, it doesn't matter. This is, so whatever network effect GitHub managed to get, they got it. They're there first. I don't know. They have a cute octocat.
It was mentioned on Silicon Valley last week.
Yeah, exactly. So they have the name that people recognize and associate with Git. And that's where a massive amount of the open source development community has moved. Like entire language ecosystems use Git as their backing store for stuff. Like specifically, I think JavaScript in their NPM system, like everybody stores their repositories on GitHub. It's just the default.
So one of the reasons is that they made it free for open source projects to do.
Yeah, right.
So they don't charge it.
Right.
So are they monetized? How are they funded?
Oh yeah, so
They charge for private.
private repositories are how their primary.
And I think they're trying to target enterprise now.
Yep. They also
Yes.
do a hosted version. Like you can get an application container that you basically put on your own server.
So almost all of Red Hat's repositories, unless it's very old, are hosted on GitHub.
Yeah. Yeah. So they were there. They have the mindshare. They're the big fish. Paul mentioned Bitbucket. So I think you said it does private repositories.
Yeah,
for free.
one of the reasons we're using Bitbucket is because we have a small company, and if you're under a certain number of people on a team, you can have free private repositories in Bitbucket, where GitHub you cannot have free private repositories. And then the pricing, even once you go beyond that team size, the pricing
But why are you
GitHub
hiding your
versus
software?
Bitbucket is
Why are you hiding your source code then?
because somebody else is paying for it.
Yeah.
We don't actually own it. That's why.
Right, so Bitbucket is a good alternative. So Bitbucket actually started out supporting Mercurial, right?
They still support Mercurial and.
Yeah, they kind of wear both hats. So
one of the things about Bitbucket, they're both very useful tools. You've probably heard of Jira as well. Same company behind it.
Yeah, Atlassian.
And they tie in tightly with that. So if you're using Jira and using the other Bamboo and all these other tools that
Right.
they have, they all integrate really nicely.
if you're sucked into that,
You're sucked
world.
into their ecosystem.
Bitbucket was Stash, right?
So Atlassian, the company, had Stash, and they bought Bitbucket.
Yeah.
I don't
think
pick it
they're
up
still-
on.
no.
They dropped Stash.
They rebranded it to Bitbucket.
Yeah.
That's interesting because internally Red Hat uses the GitHub with Atlassian tools of Jira.
Yeah, and you can do that, yeah. But if you want to use like hosting Jira and all that, and Bitbucket, they integrate really nicely and all that.
Yeah, so for folks that don't know, Atlassian's tool suite is like a big set of software as a service kind of tools that can do issue tracking and wikis and
Confluences.
continuous integration servers and a
Yeah,
lot of stuff.
all kinds of stuff.
They
All
have a
kinds
pretty
of stuff.
decent free UI for Git if you want a user interface. It's called Source Tree.
Yeah, I
Yeah.
use that.
Okay.
It's really good.
Yeah, I think even I want to say Atlassian will offer all of their tools for free if you're an open source project. Is that right? So if that's your thing, if you like all that, there's a lot of stuff. I'm not crazy about it, but
It also takes up a lot of memory.
yeah. Okay.
It's like 2 gigs to host one of the modules.
All right, cool. So anyway, Bitbucket's a good alternative, but GitHub is the big player. Now here's where I stand on my soapbox for today. I want to say if you're a developer, well, make an account. Like seriously, make an account. If you don't have an account and you're a developer and you have a computer with access to the internet right now, like really stop listening to me and make an account. I emphasize this point mostly because if I was thinking about doing hiring, like I guess I have enough of years now that I could potentially be involved in those conversations. That like if you were a serious developer and you didn't have an account, I kind of like worry about you or wonder like there's so much stuff out there and so much awesome stuff out there that if you're like really passionate about software and development, like you should at least have an account so you can dabble. Like you don't have to have projects, you don't have to do that. You just need to like prove that you know how to get on GitHub and get the tools. And hopefully I can equip you today if you didn't have that experience. But an account is kind of a baseline in my mind to say like, okay, I can believe that you're a developer. Now maybe you're really new and that's new information to you, but I think I want to say a lot of the people in the industry would share a similar mindset. It's not hard. It's just like any website, username, password, and then you're golden. So there's a bit of extra step that I skipped over earlier. If you set up your Git client and you create an account, you need to get the two things. Create an account on GitHub, excuse me. You need to get the two things to be able to talk together easily. You can do that communication over HTTPS. So if you do a clone from an HTTPS URL, you can get your repository and use essentially basic authentication to use your username and password anytime you wanted to commit. That's irritating, it's annoying, it gets really old after time, especially if you do a lot of work on GitHub. So this stuff is talking about creating an SSH key on your machine. And this is considered asymmetric or symmetric key encryption. I don't remember which one. But you create a private and public key pair on your local machine, and you basically give GitHub your public key. So that allows you to authenticate. I'm not going to walk you through that process because it's sort of mundane and boring, and I've used that particular link a bunch of times over because I always seem to lose my SSH keys or whatever. But I've done it plenty of times to go generate a new one on a new machine or whatever, and that process is pretty seamless. So what that will do is when you get a repository from GitHub after that, you can use a different style URL. So instead of https://github whatever, it'll be git plus ssh:// which is a Git specific protocol, wire protocol for transmitting information over an SSH connection, which stands for secure shell, if you're unaware. So it's very cryptographically secure, and it's how data is transmitted on the internet in a secure way.
You have multiple public keys?
Yes, yeah. I have. I'm not going to bring up my keys page, but I have a bunch that are there for like different. For example, I have a side project where I do all of my builds on a cloud machine, and it goes and it fetches from Git itself. Like when I have Ansible scripts that do configuration management and run all the steps to pull down code and get my servers configured the way that I want. And part of that process is it needs to fetch the latest code. But it doesn't have my personal key on it, so I encrypted my private key in that repository and gave it the necessary smarts to unlock the private key and access that information. So I have a deployment key, public key on GitHub just for that purpose. So yeah, you can handle multiple. It's pretty useful. Okay, so I think we're at a stage now where my slides will kind of evolve and morph into GitHub, and we'll jump back and forth about what you need to do. But let's say you find a project on GitHub, and there are tons of them. There's even they have like little collections. I don't remember the name of the page right now, but if you're just browsing GitHub, they have specific collections. So if you're like, let's say you're interested in data science, you can go to the data science collection.
/explore.
Thank you.
Yeah. Categories.
Yeah, categorizes, and there's a lot of cool stuff in there that if you're interested in civic hacking and all sorts of things, there's something in there for you probably. But let's say you've gone through that process, and now you find a repository that you either want to contribute with to or play around with or whatever. The steps that you need to take to do that is to fork a repository. And what that means in GitHub's terminology is that on their end, effectively, they will take the canonical repository, in this case KeyLUG demo is the repo that we're going to fork, and they'll make a copy for you, a Git clone, and it will have all the same information, but it will be under an account that you have write access to. That's the important aspect. Like right now, if any of you were to clone this and want to commit to this master branch, you can't, because you haven't been granted access, which is a good thing. Not that I don't like any of you, but you just don't have access yet. So what you would do is come up here and you fork it. Now I have a bunch of different accounts that it could be in, but I'm going to fork it under my personal account. So it's making a copy. They have a cute little animation. And now you'll notice up here it says MB Layman, which is my user account, demo, and that's hard to read, but it says forked from KeyLUG demo. And so forking a repository is your method of getting into the code and getting a handle on it. From there, well, let's jump to the next slide. From there, you can do something called cloning. So you have a repository, and remember, this is a distributed system. So what you are going to do next is, on GitHub servers, they've created so the canonical one and your forked repository, but you still don't have it locally. So you need to tell your Git client to clone it and to bring it to your machine. Here's where I have a piece of advice that might differ from some people. In my opinion, your local clone should actually be the upstream repository. So in that example, that's the KeyLUG demo repository. And the reason for this, I think, is it provides an easier workflow that I'm going to walk you through of why. And the alternative, by the way, is to actually do a clone of your forked repository. So remember, there were two options. I'm saying fork the original, or clone the original one, not the forked one. So let's tease out why. So I'm going to talk about two features that get implemented and different variants of that. So the first example here is you've done what I suggested. You clone the upstream repository, and now you have it on your Mac, your Windows machine, your Linux machine, whatever. You have it in front of you, and this is a project that you've done a lot of investigation on. You found two separate things that you want to fix. So what you've done is you brought it down, and you're gonna, like I said, branches are cheap, so you create a branch, which I'll cover. By the way, after all this is done, I will walk through an actual example. So this is to get you conceptually going first, and then we'll walk through the details and do some more detailed stuff with GitHub itself. But you create a branch, you make whatever code changes or documentation changes to fix the issue, and I'm going to do some hand waving about bullet point 3 because you push it up to GitHub, it goes through a pull request process, which I'll describe, and it gets merged back on the master. When you're done and you're ready to work on the next thing, bullet 4 is the key differentiator, and which is why it's in bold. All you have to do at this stage is pull, and what that means is you're talking back to GitHub and you're saying, okay, KeyLUG demo, I want the latest and greatest. Yeah.
So you clone your repository, and then I fork it, and then I pull your
terminology. Let's put it backwards.
Okay.
So you fork the repository first. That's when you diverge. So KeyLUG demo.
So you have your own
fork.
copy of KeyLUG.
You got your own copy.
And you clone that one. Is that what you're saying? Or you create a branch on that one?
No, you create. Okay.
Yeah.
Good. Yeah.
I
Good.
hate to say start over, but can you start over?
No. That's fine. It's cool. Here's where I wish I had the whiteboard and the marker.
You can if you want to.
There's no marker, but yeah, I checked. I would have done a whiteboard. It's okay. So KeyLUG demo. That is the canonical repository. You fork it. It becomes, in my case, MB Layman demo. What I'm saying here is local upstream is, I could have used local canonical repository. That's the thing you clone. So you clone KeyLUG demo down to your machine. Okay? When you create a branch, branches are local. All operations are local. So you're creating a branch that's based on KeyLUG demo. Okay? In this step 3 step, when you push, remember, you don't have write access to KeyLUG demo. So you cannot push your branch up to GitHub on KeyLUG demo. However, you do have write access on MB Layman demo. I'm just going to keep these in mind. So when I push, the only reason I had to fork to begin with is I needed a destination that I could send my branch. That's the key.
So when you do your pull on step 4, you're pulling from the
Yeah, so what's going to happen is if it's like a triangle, upstream, I pulled locally, I've got my branch, I did the fork, so the fork's over here. I'm done with my change, I push up my branch. Step 3 gets the changes back over to upstream.
So you're sending a pull request to upstream on step.
Yes, step 3, I will send the pull the request.
Yeah, I think the confusing part is the fact that you're pushing after you've pulled the actual real owner's master branch down, and that's the upstream, and you've already forked over into your own private sort of GitHub repository there. Then after you've made the changes on that branch, when you push the branch back, how you get it to push the branch back to your repository
It's
instead
a little
of trying to push
it's a
to
little
theirs.
weird there, and that's a key difference. But
And
I'll
what happens
explain.
changes in mid-flight. Like the change occurred after you push to your fork.
Sometimes it may not matter, sometimes it may.
Okay.
So
So
I'll
the
cover it.
question I have with this workflow though is that, let's say B depends on A, so I clone the upstream, even though I forked it already, and I push the branch to my fork,
Right.
and then I send a pull request to the master, to the upstream owner. I then should wait until he merges before I fix issue B, basically.
Yeah, or alternative. So that's one strategy. If you can't wait, you can also branch. You can do your local thing. You don't have to work from master. You can branch again on your local thing.
And you're expecting him to accept your
Yeah, if you're
fix, but if
expecting
he
him to
doesn't,
accept.
then your B branch is kind of hosed because they didn't accept it.
Right. Yeah. So there might be a whole complicated dance around that particular scenario. I'm kind of covering like the happy path for now. It's complicated enough. Patrick, can you turn on the lights? I'm gonna make this guy go up.
The same thing. Silver box.
Lift up the cover.
Same thing. Alright.
Is that kind of play?
Alright, this is complicated. I promise once you get over this hurdle, we'll have to do that. It should be better.
All right. So we have KeyLUG demo is our one repository. So step 1 was I forked. Because I don't have write access to this repository at all. So now I have MB Layman. Spell my own name. Let's see. MB Layman demo. Step 2 is I run Git Clone. I haven't showed you that command yet, but that's the command. And I pull this down. Let's see. Dividing line. This is the cloud. This is GitHub. And this is your local machine. Okay? I've got a local repository of KeyLUG demo. So I said the next step was I need a branch. So I'm going to make a branch. I won't bother explaining, like, it's just a pointer, but whatever. So here's my branch, and I do my fix. Right there. And so this branch is what I ultimately want to get up in here. But I don't have write access to that, so I can't just push up that branch. So what I'm going to do instead is take this and push it up here, and it becomes a branch off of my online version, basically. There's a set of tools from this step that GitHub has that will help me get this branch into here. Okay.
You don't want to actually have to be like that. Have a branch. You want to merge master. You want to take your branch and merge it to their master.
Yes, take my branch, merge it to their master. Exactly. So if they finally accept it, we'll call this KeyLUG 0. That's their first state. And this is KeyLUG prime. So now that I'm done with that process, branches are cheap. I don't need this anymore. But this was at key 0. This is still stale. So what I had in step 4 there is now the important part. I'm going to pull, so I'm going to say, hey GitHub, I want the latest from master. And it's going to pull down key prime.
And that has your changes in it.
It has my changes. It's a bit of a circuitous route, but it has my
But
changes.
it also picks up any other changes that other people have committed to.
Yes, it does. That's probably a pretty important part. So now, feature 2. I mean, I'm not going to draw this all out, but branch, it's the same model, goes back up here, goes over there, and then you can pull it, rinse, repeat, you know.
So I kind of like this workflow because if you had been working in your forked area the whole time, then it's the Big Bang Theory of testing where you're going to push all kinds of changes upstream.
Potentially,
and
yeah.
that guy's going to be like, no.
Right.
It's almost like a DevOps approach to it.
Yeah, the idea with this is like you want to keep branches like a few commits, maybe keep it really small and keep tightly integrated with whatever master's running. It's a very agile flow. So I've worked on projects and contracts that have a massively complicated branching architecture, WinT being one of them. That just like have release branches all over the place and long history branches, and what the problem that you encounter is those big change sets when it comes time to like, okay, I need this change set that was on this patch release that was deployed in the field to get back onto the main trunk. Like, that's troublesome. It becomes hard. So if you can kind of constantly integrate features and have your master branch just be the latest and greatest of everything you care about, then it just makes your life easier.
Are you aware of
conceptually.
open source projects that follow this flow? I mean, is this something you created, or is this something you
This is
learned?
not. I do this at work. I mean, this is it's just one method. So I'm going to cover the other method. It's not okay. The other method I'm about to describe is not like awful. It's very similar in a lot of ways. The key difference is like this arrow. So this is basically by doing this life cycle, it's a simple pull, and you always have this like reference of I have my master branch, and it makes it kind of easy to mentally comprehend, at least for me. And if I've confused you all, I'm sorry. But have any questions about this before I go on to the second one? Yeah.
Then, in order to keep your fork up to date with the master, then what would you end up doing to clean that up? Or you still left with that branch?
That's a really good noticing the detail there, the missing detail. You're right, because this will stay basically at key 0 until I push up to there. It's not a problem in this regard. So I get down here, I make my other change, I want that to go back up. What you'll be doing when you push this branch is you'll actually be pushing all of that, the whole chain, like all of the history. So
that's kind of clever. So you're rebasing to the upstream that you're doing it.
Yeah. So where this gets bad is like I work on a really big repository that we commit images and all sorts of things to it because we're a website and we want all of our web application to just be in one place. So occasionally we have like new pages that we have that have heavy payload kind of PNG files and stuff. And so where this can get slow is if you did this for a long time, like every time you make a branch, you're pushing up some redundancy. So if there were like 8 megabytes worth of changes in here, what you probably want to do is go ahead and actually push that up. Because when these two talk, when you do this push, it talks to the server and says like, here's what I've got, what do you have? And then it does that negotiation, says, okay, you're at K0, I'm at K1, or I'm at K2, I'm going to give you everything from 0 to K2. So the occasional push like kind of spruces up your clone, if you will, but it's still it always just tracks master. in the end. All right, so let's talk about the second slide I have. You can picture it. Oops.
And probably wet that towel.
If you make it quite damp real quick.
Yeah. So the second version was similar in most ways.
Slightly damp.
Okay. Perfect. Thanks. With a distinction. So the first thing that you do is the same. You fork the repository. Okay? This time though, when you do your clone locally, you're really bringing down this one. So initially this doesn't matter because like if you just forked and then cloned, you're going to be up to date. So now you make issue 1, you do your commit, and then you do this process of my branch still needs to come up here. Here comes this branch, this chunk needs to come over here. Okay. The difference now is that before you can branch here, like last time I just did a pull. Okay, so this thing is still advanced to K1, but now what I have to do is a merge rather than a pull. It's a little nuanced, and the difference, like on the command line, it might. So git pull is the first model. It knows the upstream that you have, or what's considered the origin. And so we'll just pull. In this model, since like this thing is still stale, I can't say git pull because it doesn't have K1 because I didn't do anything to get K1 over here. Remember this is a separate branch. So I have to, on my local, I can say Git Merge, and then so that's really the only like difference at a superficial level. But unless you pass on certain extra flags, there's a certain feature called a fast forward flag. Like you can run into trouble with merge because what it can do, if you're not paying attention, it can create an extra commit. So a merge in Git's terminology takes content from one and content from another and brings them together and makes a new commit, unless it's very smart and can see like the only stuff that's changed is stuff in this side, and that's called a fast forward, where it just skips the extra commit and just says, all right, we'll just give you this new stuff. It's not worth fretting about too much, except that you should just keep in your head that this can be more difficult to manage, which is why I opt for the other flow. So this is the key point, pull versus merge. And I can walk, so anybody who's like interested in more of the why that's can be problematic, I can walk somebody through it after. But I think you could probably just like done enough like hammering your brain with all these different flow diagrams.
And I think what I frequently run into is when I get confused with all this stuff or it doesn't seem to be doing what I want, I delete.
Right.
Like reclone. Like
yeah.
I'm just like I'm done. I don't want to figure this out. It's too complicated. And that's why I sent you that XKCD like link where the guy was like, well, whatever with your theories of like branches. I'm just gonna start over.
Yeah, exactly.
If you've made changes and you've done a fix in one of your branches, and is it possible to delete and start over with a fresh pull and still keep your changes? You end up merging again locally.
If you like take the nuclear option and you delete the whole
repository. That is a nuclear option.
No.
How do you save your
So Git has tools that allow you to like, let's say you did a bad merge by accident.
Okay, yeah.
And you have some commits that shouldn't be there. Remember, this is just version control.
Just back out of it.
So a quick search on Stack Overflow will show you like, here's how you roll back a few commits. So you can say, I screwed up, sorry. And that way you can then undo the damage you may have done, figure out
Because I think the delete survivor option is wiping out history. It's just wiping out all the history.
Yeah, exactly. It's just, it's like, that's why I call it the nuclear option. It definitely is nuclear.
Could
So-
you save your fix work off something else? You do a fresh pull and then merge your fix into your.
So I've done
Yes.
that. I'm like, I've changed these files. I have no idea how the hell to ever get this back in the way it was.
Is that what stash
I copy them
helps with?
somewhere else, blow it all away, bring them back, and then do one commit. And then it's
Yeah.
good.
So Git has some tools that Chris just mentioned. One of them is called Stash. So let's say like you haven't even committed it yet. It's not a change. It's not even on a separate branch. It's just you've been dabbling. You're like, I think this is important. I want to keep this around, but I'm not ready to commit it yet. It's just not done. Git has a feature called Stash, which essentially takes your diff and it kind of packages it up, puts it off on the side a little bit, and then brings your master back to its pristine state and keeps the stash separate. And it keeps like a stack of them, so you can just pull them whenever you need to. So you could, in theory, like if you're having a troublesome time or you're waiting for an upstream fix on something but you're not ready, you could stash your changes to put them off to the side, pull down the new stuff, and then reapply your stash, which will then just try and it's like a patch algorithm that will just try and treat that thing like a patch and put it over the top. And if it still maps, it will say, cool, here are your changes. If you suddenly have a conflict, then you have to resolve conflicts.
All the hashes would have to come out right.
It's not at the hash consistency level. It's at the it's like an old school CVS. You create a patch file for any changes that you have. That's kind of what Git is doing with the stash. It treats it like a patch, and then when you want to take it and reapply it to your branch, it basically runs the patch algorithm to say, here's this diff. Does it map cleanly onto this updated version? If it doesn't, it will give you some difference markers to say like, hey, you made change on line 2, but so did master. Here's your version, here's their version. Figure out which one's the problem. That's on you. Because the computer's not smart enough to do that. So that's kind of a flow. I think I'll jump back into the presentation. Hopefully, thank you guys for indulging me and digression down to the flow.
No, it's okay. Your computer's you're sleeping.
Yeah, last time I went to sleep, I couldn't get back on the library internet. There we go. Let me just check that real quick, if that's going to be a problem. Okay, awesome. So, yeah, you can see we covered all this in detail on the whiteboard, but that's the only difference is this merge versus pull concept. But at the end of this, if it's easier for you to do one versus the other, just go with it. It's not going to be detrimental to you in the long run as long as you're aware of what you're doing. All right, I think we're ready to play with a little bit of code now. My favorite part. Okay, so what I've got here is KeyLUG demo. It's got a different directory name, but that's fine. So here are a few files that are in there. In your repository, it keeps track of what's considered.
Yeah, it's on. Yeah, you can. Oh, bummer. There we go.
Yeah. Format solution. Just move it over. So in your repository, it keeps track of where I got the clone from. So when I cloned this, I cloned it from this destination, and by default, just conventionally, this is not actually something that's hard-coded into Git in a meaningful way. It calls it origin. So that means that this clone came from me going to the GitHub site and doing what the strategy that I talked about of cloning from the upstream rather than the 4th version. So let's look at GitHub for a minute, and let's go back to the repository. So what we're going to try and do is fix an issue. To give you guys a flavor for what the workflow is like. That issue says, give Tim Peters credit for his work. In this repository, I have a file called Zen. This is a famous little poem in the Python world, and it's called referred to as the Zen of Python. And actually, if you ever, it's a little Easter egg in Python. Yeah, if you launch a Python interpreter, that's where I'm at, and say import this, you get the Zen of Python. Beautiful is better than ugly, explicit is better than implicit. You guys can read. But it's a set of heuristics that Python kind of likes to follow when thinking about language design, and it's got some cute little jokes in there too. But the key thing about the issue is I said give Tim Peters credit for his work when I wrote this at 11:30 last night. And the reason for that is if we look back at import this, okay, I've got all this text here, but I missed, oops, I didn't actually give him attribution in my version. So in my version, if I can type Python Zen, I print out the Zen of Python, but it is sans Tim Peter accreditation. So what I want to do is fix that. Pretty simple fix. We're just going to add some text, so no scary coding here. If coding is not your thing. So, oops, sorry. I use ZSH, which is a different shell from Bash, and I have Git. ZSH comes with a Git plugin that has aliases for most of the common operations. So I was just about to do one of my alias conventions, but you guys won't know what the heck I'm doing if I do that. So let's try it a different way. So can you all read that? It says git checkout -b. So that means I'm going to make a new branch. I'll just call it Tim Peters. Cool. So I've created a new branch. My shell is smart enough to tell me that I'm on a different branch. So it knew I was on the master branch. Now it knows I'm on the Tim Peters branch. You can see here, oops, sorry. Git branch is a command that says which branches you have, which branch you're on, with the little asterisks and the dot. So I can switch back and forth because branches are cheap and everything's local, which is an expensive operation in a different tool like Subversion. So I can say git checkout master, and now Git is giving me some information that I'm back on the master branch, and if I do git branch again, okay. You guys got that concept? Pretty straightforward, right? So let's go back to the Tim Peters branch, and now we want to give him some credit. So it's Zen of Python by Tim, I keep calling him Time Peters. Okay. Alright, so again, this is the cleverness of my shell. It knows that I have some changes, so it gives me that little X there to tell me that something is different about your repository versus the master state, or the state of things. I can run Git Status command.
Can I have the parents, Dolores and Santiago Hernandez come to the circulation desk? Thank you. Dolores and Santiago.
Nice library interruption for us. So I ran Git Status. This is a bunch of information from Git again. It tells us I've modified ZenPy, which you all saw me do, so you know it's right. And now I can run git diff, and it will tell me specifically here's the changes that you made. Okay? This is just a diff format, so it's pretty easy. The pluses are lines that were added. It's colorized helpfully, and if I took anything out, it would be red with little minuses. So that is the change that we want. So Git has this extra concept that's referred to as a stage. So whenever you're working on something, you make any changes, it's not ready to be committed yet. Like if I try and do git commit, it's going to say change is not staged for commit. No change is added to commit. So Git has some extra tools that let you tease apart like the parts that you want to add. So let's say I had the Zen of Python line added, but I also added some other new feature to that script later on, but I wanted to commit them separately. It's possible to tell commit to take tell Git to take an individual file and say, get ready to commit this part, but skip this part, so you can keep things isolated. That's not worth going into depth on, but just so you know it's there. This is the reason for this staging thing, is to give you this extra layer. It's an extra abstraction, extra flexibility to enable that kind of thing. So the first thing we need to do is we need to tell Git, hey, this is the stuff that I want to commit. So now I want to add it. If we look at Git Status again, it's good. It changes its message. It went from red to green. It says, hey, we now have stuff that is ready to be committed.
And you notice Git diff won't come up with anything now.
Yes, but you can pass an extra flag.
Yeah.
So if you did, so you're right. If you did git diff, it's no longer in your diff. It's been set aside and put in this staged environment and is now ready to go. But if you did git diff cached, it'll tell you what's in your stage. It's useful to know sometimes. So now we are ready to commit. Tim needs his credit. This next bit that I'm going to show, I'm going to say fixes number 1. You might have dealt with this in different bug trackers or different source control tools, where if you have a tight integration between, say, Jira and Subversion or Jira and whatever, if you give special patterns, it can do like the association automatically of what issue goes with what code. So here, by saying specifically fixes, and then, or I think it has some variants like fix or something, but you can find that on GitHub. It will tell GitHub this code is related to this other issue, and the Tim Peters issue was issue number 1. So now I'm